What's up, cosmic explorers? Get ready because today we are diving into one of the most mind-blowing mysteries of the entire universe. I want you to start by using your imagination. Imagine you are at a big, crowded party, and suddenly you notice a group of people dancing. They are all spinning together in a tight circle. Now, think about the logic of that movement. If the people standing right in the center of that circle start to spin very, very fast, you would naturally expect one of two things to happen to the people on the outer edge. Either those people in the center would have to drag the outer people along so they spin just as fast, or the people on the outside would simply fly off and lose their grip due to the sheer force of inertia. It makes sense, right? It is how we expect the world to work. But as we are about to see, the universe is much, much stranger than any party we have ever attended. A few decades ago, a truly brilliant woman and astronomer named Vera Rubin became absolutely obsessed with a specific question. She wanted to study exactly how galaxies rotate. This was no small task by any means. When we talk about galaxies, we are talking about enormous, mind-boggling collections made of billions of stars, vast clouds of dust, and massive amounts of gas. All of these components are swirling together like a gigantic cosmic whirlpool. Vera and her dedicated team spent their time observing hundreds of these spiral galaxies, including ones very much like our own home, the Milky Way. Their goal was to measure the speed at which stars rotated within these systems. They wanted to know the speed of the stars packed into the center compared to the speed of the stars way out at the edges. What Vera Rubin discovered during this research was nothing short of insane. To understand why her findings were so shocking, we have to think about the laws of physics as we see them in our own backyard, the solar system. Think about the planets orbiting our sun. Mercury is the planet closest to the sun, and because it is so close to the center of gravity, it moves at a blazing, incredible speed. However, if you look at Neptune, which is way out there in the cold outer reaches of the system, it creeps along quite slowly in its orbit. This is exactly what we expect to see. We expect this because the gravity of the sun is much stronger when you are up close, and that gravitational pull weakens significantly as you move further away into the distance. Because of this, Vera Rubin and other scientists at the time expected to see the exact same pattern occurring in galaxies. They assumed that the stars located in the dense center of a galaxy would spin super fast, while the stars at the very edges, far away from the galactic center, would be moving much more slowly. But that is not what happened. Not at all. What they found was a total shock to the system. The stars at the very edges, those lonely stars that should have been barely moving at all, were actually moving almost at the same speed as the stars located right in the middle. It was a complete defiance of what they thought was possible. It was like watching those dancers on the edge of our party spinning just as fast as the people in the very center, but without any visible way for them to stay attached. There was no one visibly holding onto them, and nothing visible was propelling them forward at those speeds. According to everything we knew about gravity and all the visible matter we could see, this was impossible. It was as if some kind of invisible force, a type of cosmic glue that we simply could not see with our eyes, was holding onto those edge stars and preventing them from being flung out into the dark emptiness of space. This created a massive question. What was this invisible thing? How could it be there, dominating the entire dance of the galaxy, without anyone being able to see it? This paradox was so vast and so confusing that scientists initially did not know how to explain it. We rely on Newton's laws of gravity for almost everything in space, from sending rockets to the moon to predicting how planets will move. Those laws stated very clearly that if the outer stars were moving that fast, the galaxy should have simply disintegrated. All of those stars should have gone flying off into intergalactic space, scattered like dust in the wind. But they stayed. They were right there, firm and in place, as if a giant and completely transparent hand was holding them together. The only way any of this made sense was if there was much more mass in those galaxies than we could actually see. Going back to our party analogy, it was as if the dance floor was made of an invisible, extremely heavy material. Even if you could not see this material, its presence and weight would prevent you from leaving the circle. But the mystery only deepened when they tried to find this extra mass. It was not made of stars, because if it were, we would have seen them shining. It was not made of gas or dust either, because our telescopes would have detected those things as well. Something else was there. This mystery led to the birth of one of the most revolutionary and perplexing ideas in the history of modern science, and that is the concept of dark matter. Now, it is important to understand that we do not call it dark because it is simply hiding in the shadows. We call it dark because it does not interact with light at all. For those of you who enjoy the technical details, this means it does not interact electromagnetically. It does not absorb light, it does not emit light, and it does not reflect light. It is literally invisible to every single one of our instruments that detect electromagnetic radiation. From radio waves to gamma rays, dark matter remains hidden. It is like a cosmic ghost passing through the universe. You can think of dark matter as a kind of invisible scaffolding. It is a structure that extends far beyond the visible boundaries of every galaxy, enveloping them in a gigantic, invisible halo. This halo of dark matter would be the true gravitational muscle of the universe. It is the force that holds the edge stars in place, allowing them to spin at that improbable, high speed without the galaxy falling apart. Vera Rubin's observations, which were published in the late 1970s, were not just a one-time fluke. Other scientists had seen clues before, but the systematic work of Rubin and her team was what truly changed everything. By measuring the rotation curves of so many different galaxies, she put the problem on the table as an undeniable reality that the scientific community had to face. The concept of dark matter was so radical that many people were naturally skeptical at first. The idea of mass that we cannot see or feel sounds more like science fiction than actual science. But as time went on, more and more evidence began to pile up from different corners of the universe. For instance, we can look at galaxy clusters. When we observe these massive groups, we see that the galaxies within them are moving way too fast. Based on the visible mass of the cluster, they should be flying apart. Without dark matter acting as an invisible force field to coalesce them, these clusters should have dispersed eons and eons ago. Then there is the evidence from gravitational lensing. Gravity has a very special property: it bends spacetime itself. This means that light traveling from distant objects will actually curve as it passes near large concentrations of mass. It works just like a giant glass of water that bends the image of whatever is sitting behind it. We have actually seen the light from distant galaxies bend in ways that can only be explained if there is much more invisible mass present than what we can see with our telescopes. We have even seen this in action during collisions between galaxy clusters, like the famous bullet cluster. In those events, we see the normal matter, which is hot gas, collide and slow down. But the dark matter does not interact, so it passes straight through, leaving a clear separation that proves it is really there. We also see the influence of dark matter when we look at the large-scale structure of the entire universe. When scientists run computer simulations to see how the universe evolved from the Big Bang to the present day, the models simply do not work if they only include visible matter. The galaxies and clusters we see today would never have formed. To make the simulations match reality, they need an enormous amount of dark matter to act as the foundation. It is like trying to build a massive skyscraper without an invisible steel structure inside. Without that dark matter support, the whole thing would simply collapse. Today, the evidence is overwhelming. Dark matter is not just some extravagant or wild idea, it is a necessary explanation if we want to understand how the universe works on a large scale. When we look at the big picture, we estimate that dark matter constitutes approximately 27% of all the mass and energy in the cosmos. Think about how massive that is. Everything we can see and touch, everything around us, the stars, the planets, and even ourselves, barely represents 5% of the universe. The remaining 68% is something called dark energy, which is even more mysterious, but that is a story for another time. Despite all of this indirect evidence, the million-dollar question still remains: what exactly is dark matter? The truth is, we still do not know for sure. The most popular guess among scientists is that it is made of subatomic particles that do not interact with the forces we know, except for gravity. We call these WIMPs, which stands for weakly interacting massive particles. Right now, there are gigantic experiments happening in underground laboratories all over the world. These labs are buried deep underground to shield them from all other radiation, as scientists try to detect these particles. They are waiting for that one rare moment when a dark matter particle might collide with a normal matter atom. It is like looking for a needle in a cosmic haystack, in total darkness, hoping the needle might emit one tiny spark. There are other theories too, of course. Some suggest particles called axions, others think about primordial black holes, and some even suggest we might need to modify our understanding of the law of gravity itself. But so far, none of these have been confirmed. This leaves us in a state of wonder and constant searching. The legacy left behind by Vera Rubin is absolutely immense. Her curiosity and her persistence opened a window into the most enigmatic and hidden part of our universe. Because of her work, we now know that we live in a cosmos where the invisible is not just a strange exception, but the actual rule. It is a powerful lesson in humility for us humans. It is an invitation to keep exploring and to keep asking questions. The next time you find yourself looking up at the stars, remember that there is a mysterious force out there. There is a cosmic ghost holding those stars in place and dancing with them. It reminds us that the realm of the invisible is much larger and much more fascinating than we ever imagined. If you enjoyed this journey through the invisible parts of our galaxy, make sure to hit that subscribe button and join us for more cosmic explorations. For more information, visit minrora.com.